right, so thank you for making it to our session. Let me introduce ourselves first. So I'm Jiří Tomášek, and this is Danny Beckett. We are both on the SUSE Edge team. This talk is going to be about multi-tier management and observability of the edge clusters with Rancher. This is not based on any actively or any product which is currently released. It's basically an update on the work which we have been working on in the past months and how we are approaching the solution for the problem which we were going to describe. All right, so what we are going to go through. So first we're going to touch on the multi-tier Rancher management model, which we introduced to solve the problem which we're going to describe. Next we're going to introduce some new terminology which we had to use to be able to describe the solution. Next we're going to take care about monitoring stack, which is the crucial part of the whole solution. And finally we're going to showcase the user interface extension, which is exposing the results of the work in the Rancher UI. All right, so what's multi-tier Rancher management model? So before we get to this, if you attended previous edge sessions, you have probably seen very similar slides such as this one. So what is the motivation, basically, which leads us to having to solve this the problem? So with the Edge, we are facing environments where we are managing from hundreds to tens of thousands of clusters, and we are quite often hitting the management at scale challenge. So some of our customers are pushing the boundaries in terms of what are the current capabilities of the clusters management with the single Rancher manager, and we are hitting the user experience problem. So we would like to maintain the user experience even for the management of very large numbers of clusters. At the edge specifically, the clusters are supposed to be very lightweight and focused on running the workloads, and we don't want to really bloat them with like a heavy monitoring stack running on top of these clusters. So these should be very lightweight. And with these large number of clusters, we want to have some kind of, or many kinds of, or different kinds of grouping employed. So we want to have location-based grouping of the clusters, responsibility-based grouping, and so on. Right, so the goal of our work is obviously to be capable of monitoring and managing many thousands of clusters. On top of that, we want to provide a dedicated user experience for this solution. And while we want to introduce like a top-level overview of all the downstream clusters, at the same time we want to be able to drill down into a single downstream cluster and be able to manage that cluster as in normal way, which you do with the Rancher management cluster, with the Rancher manager. We want to introduce a observability dashboard, which is going to use an aggregated data and give you this high-level overview of all the downstream clusters which you are managing. Of course, we are talking about the scale of tens of thousands. And finally, as I mentioned before, we want to have the actual workload clusters need to be lightweight as possible in terms of monitoring and similar workloads. So this is most likely what we all know, the standard Rancher management model, where we have a single Rancher management cluster, and this manages the downstream clusters. As we increase the scale and add more and more downstream clusters, we may start to hit some boundaries of this existing model, and we need to try to overcome that problem somehow. It's not only the problem of scalability or performance, it's also a problem of user experience, because you need quite different user experience when you're dealing with, let's say, 100 of clusters and tens of thousands of clusters, of course. All right, so at this point, I would like to point out another talk which is happening tomorrow. And this talk is by Rafael Applets and Silvio Moioli. Silvio is also here. I don't know about Rafael, haven't met him yet. So their talk is going to be focusing on rancher optimizations and fleet optimizations regarding the performance and so on, because they are part of the team which is dealing specifically with these problems. So I highly recommend to visiting this session. And okay, let's continue. So this is what we are introducing. So basically, from the standard rancher management model, we are moving over to the multi-tier rancher management. So what we are doing is that as we grow the scale, we are adding more rancher management clusters, which are now forming this centralized or this middle layer. So we have a set of rancher management clusters managing their own downstream clusters, and this is how we are capable of increasing the scale as needed. And on top of these rancher management clusters, we are employing one more rancher management cluster, which is managing these rancher management clusters. And as you can see, I'm repeating rancher management clusters, so that's why we need to introduce the new terminology, which is hub, spokes, and downstream clusters. So this is the same diagram. Just you can see that at the top, the rancher management cluster is called hub cluster, and the mid-tier clusters are the spoke rancher clusters. All right, so what is the role of these individual cluster types? So, of course, from our observability point of view, the most important one is the top one, the hub rancher cluster, because it manages a set of spoke clusters as a normal downstream clusters. And it also receives an aggregated information about each spoke's downstream clusters. So we basically need to find a way how to get the spoke information, the information about the downstream clusters, which lives on the spoke, and get it all across all the spokes onto the hub. And also the hub provides the user experience, so it provides an observability dashboard, which is giving the user the overall information about all the downstream clusters which we are managing. And at the same time, it provides the drill-down functionality which I described before, basically being able to easily and quickly get to the management of a single downstream cluster. Moving on to the spoke rancher cluster. This is a standard rancher management cluster managing the downstream clusters, and it provides an aggregated information to the hub rancher cluster. Finally, downstream clusters mostly focused on running the workloads. They don't run any heavy monitoring stack, and they are registered and managed by the spoke clusters. All right, so now the actual solution of the problem lies in the monitoring stack. So the backbone of the whole solution is Grafana Mimir. We were searching for various options, and Grafana Mimir came out the best for us. We're going to describe why in later slides. So in short, Grafana Mimir is basically a time series database which provides a scalable long-term storage for metrics for Prometheus. Yeah, Danny, go ahead.
So, as Yuri mentioned, we're going to be using Mimir on the central cluster, and this slide provides a high-level overview of the monitoring stack. So, on the left, we can see Prometheus, as well as Prometheus Agent and Grafana Alloy. These will be expanded on later, but what you need to know is these are responsible for gathering metrics from Rancher and then remote writing them to the central Mimir instance. And then from here, using Grafana, you can query any data that Mimir holds and be able to quickly see any information about any downstream cluster that's managed. So some more information about Mimir. As Yuri mentioned, it is a time series database, and it allows for up to 1 billion active metrics or more, and it's extremely performant, featuring multi-level caching and query sharding. This is extremely important for the use for our use case where we're trying to manage tens of thousands of downstream clusters, meaning that a lot of information is going to be sent to Mimir at once, and we need to make sure that Mimir doesn't get overloaded. This comes with horizontal scalability and high availability through replication. This will be touched more on later, but this is just to highlight, the scalability of Mimir. Furthermore, it supports a wide variety of block storage, namely Longhorn, which is deeply integrated in the SUSE Edge stack, and also has a built-in multi-tenancy, which means that it's very easy to configure which users have access to which information using the Grafana dashboard. There's a future promise of supporting OpenTelemetry, which at the moment we're using a Prometheus exporter, but down the line, OpenTelemetry might be a more robust solution depending on the environment, so it provides some nice flexibility. It's also battle tested on large-scale environments, namely Grafana Cloud, so that also just demonstrates its reliability for our use case. And it's very easily installed on top of the current Rancher monitoring setup. It's as simple as going to the Rancher marketplace and grabbing it from there. So more on Mimir scalability. As mentioned before, it allows up to 1 billion active queries, and it also supports safe scaling with no manual intervention, meaning that depending on how it's configured, when it's being overloaded, it'll automatically scale itself up. Now, Mimir runs in 3 distinct modes: the monolithic mode, read-write mode, and microservices mode. So for the monolithic mode, you can safely scale up any number of instances of Mimir as a whole. And for read-write mode, you can individually scale up the read, backend, and write components by themselves. You can also safely scale down the read and backend components. For the microservices mode, you can scale up any component individually, and you can also scale down any stateless component. More information on that can be found at this link.
So having Mimir as a centralized storage for the metrics, we're moving on to the spoke management cluster and what runs there. So basically, we're running a standard Prometheus installation, and on top of that, we have a custom created Rancher Prometheus exporter, which basically exports the metrics based on the resources from Rancher, which are available on the spoke management cluster, and this creates the aggregated data and remote writes them to Mimir. So basically the stack which runs on the Rancher management cluster allows us to take the data which we are interested in about all the downstream clusters and store them in Mimir on the hub.
So to supplement what Yuri just said, Prometheus exporter gathers the information from the Rancher resources, all of these metrics, some of them being highlighted above, and then it remote writes them to the central hub, the Mimir instance running on it. Now, some of the information we gathered include the status of the cluster, so whether or not it's connected and disconnected, as well as the condition of the cluster, so things like if it's pending, waiting, ready, and also physical things such as the memory pressure and the disk pressure. It also specifies like the name, display name, and version. Now, this information is very minimal, the reason being this is just a proof of concept. So for the actual product down the line, it would be expanded on further. It'll also be customized depending on your environment. But like I mentioned, it's just for the proof of concept. Now, Prometheus uses the protocol for transferring time series data. This is what allows for remote writing, and it allows many Prometheus instances across any of the spokes to actively write to the central Mimir instance. So in order to enable the remote writing, we have to modify the existing Rancher monitoring configuration. So we add 3 distinct portions here. So first, we supplement the external labels so that the information gathered by Prometheus is tied to information. So things like naming the spoke and the location of the spoke using longitude and latitude. Additionally, we specify the remote write tag, so we give the name of the Mimir instance that we're using, and we also provide the URL that Mimir exposes for remote writing. Lastly, we use the right regex label configs so that we can provide a regular expression to simplify the data that Prometheus is sending to Mimir. This is to prevent Mimir from being overloaded with data that we're not going to end up using for the metrics.
Right, and finally we're getting to the downstream cluster. As we said before many times, this is supposed to be workload-oriented cluster, so it's running very minimal. So it's running just the Rancher agents, which are standard part of the Rancher management. And optionally, it can also run the Grafana agent. And basically, Grafana agent allows us to remote write some scraped metrics directly to Mimir from the downstream cluster. So just quickly go over what the agent does is it's a lightweight telemetry collector. So it's compared to Prometheus, it doesn't store any data. It basically just scrapes the metrics and remote writes them to Prometheus, to Mimir in our case. It has been designed with the edge in mind. Exactly for this reason, and it also allows for extensibility of our solution. So, what do we think? So let's have an example that let's say a customer is running multiple factories, and there is a cluster for each of these factories, and the cluster uses Acri to control the machinery as part of that factory. And we could easily define a Grafana agent which will scrape the metrics from this machinery across all the factories and ship the metrics information into the hub. And you could easily define a dashboard which will give you the information which they are interested in about the machinery across all of their factories, and it would be visible on the hub on the central place. All right, to finish the whole architecture, we're getting back to the hub management cluster. We're utilizing Grafana and Grafana dashboard to query the Mimir, and we have created a custom Rancher UI extension which exposes this dashboard directly in the Rancher UI. All right, so now about the Rancher UI extension. So it adds a new top-level navigation item to the Rancher UI, and this exposes a dedicated page which shows this custom dashboard within the Rancher UI. And this dashboard also includes a custom-created dashboard panel, which gives the real-time overview of all the downstream clusters across all the spokes. And at the same time, it enables drill down to directly manage a specific downstream cluster. So this is what the UI extension looks like. And I'm going to also start the demo. So this is the Rancher UI on the hub cluster. And you can see that on the left we have a new icon which says Cluster Hub right now. And clicking on that opens the new page with the dashboard. Currently, this demo only features only 14 clusters, but we are, of course, expanding this further to actually fulfill the scale requirements. So on the top left, you can see some aggregated information about how many downstream clusters across the spokes we are managing. Below that, we are seeing the representation of ready and not ready clusters. And below that, we have the Kubernetes versions which are running across these clusters. The bottom part is focused on the spokes. Let me skip quickly to that. So you can see a map. As Danny described, we are gathering the location information about each spoke and exposing that as part of the metrics. So we have two spokes. One has a location in Munich and one in Prague. And when we hover over the dots for each cluster, for each spoke, we can see some additional information such as spoke name, the management URL of that specific spoke, the location information, and the number of managed clusters. And similarly, on the right side, we can see a list of the spokes which we are maintaining, again with the venture management URL and the number of managed clusters. The interesting part is at the top and in the center. So at the top, you can see a time-based history-based status of all the downstream clusters. So we can see how many clusters have been ready and how it changed over time. And when I move over or proceed with the demo, you can see that it changes real time as we are changing the status of the clusters. And the same applies to the middle section, which is that custom Grafana panel which we introduced. And here, the goal of this panel is to provide a real-time information about each of the downstream clusters. So when we hover over each of the tile, we can see the cluster name, and the initial information which is visible from the beginning is the color coding. So basically, we have a top-level overview of all the clusters, of all the downstream clusters which we are managing, and by color coding, we are quickly able to identify which of these clusters have some kind of problem. And when we click on that on the specific tile which is of our interest, we are getting a pop-up window with additional information about the cluster. In our proof of concept case, this is the cluster name, the management cluster name, and some status information. And most importantly, we have this manage cluster button. Let me just get back slightly. So we have this manage cluster button, which enables the drill down approach. So basically, within 2 clicks, 1 click of opening this dialog and 6-second click on the manage cluster button, we are getting into a new window which opens a spoke rancher management UI, and it opens it directly at the page of that specifically selected downstream cluster. So from this place, we can do whatever we need with the cluster directly in place. And that's all for the demo and for the solution. Thank you, and yeah, and if you have any questions, we are happy to try to answer them.